evaluating functions. Quadratic functions. Now let's start at the very beginning. Remember that quadratics, and we're going to be working in quadratics for quite some time, maybe the next month, doing different things with quadratics. So a quadratic means that it's a polynomial with a degree of 2, which means the largest exponent in the polynomial is a squared, okay? That's a quadratic. Now, let's talk about function. A function is represented sometimes by an f, but let me explain what this looks like. You're going to see this on the very first page. Do you see where it says f of x? That's the way you say it, f of x, f of x. And what this simply means is f is just a name we gave to this rule. This is a rule right here. And this is, we call this f. Now understand that you could have an m of x, you could have a k of x, you could have a p of x. They name them with different letters. And then this variable that's inside the parentheses simply says, in this rule that I made up, there are going to be a lot of x's in here. That's all this means. So on your worksheet, f of x simply is the name of the rule that they gave you. Now I'm going to go ahead and write number 1 up here, and then I want to explain another thing about functional notation. Functional notation. This is called don't get all wrapped up in this. This is just a title. It tells you this particular rule that we're working with, I decided to call it F. And in that rule or that equation or that expression, it's going to have some X's in it. That's all this means. Okay? Now I need some room, so make sure that you got this down or you go back to the YouTube to watch this because I need to erase. So I have room to work. Okay, and the easiest way for me to explain today's lesson is simply to do one. Excuse me 1 minute. We need to get this for Wyatt. So sorry, sir. This is what we're working with today. Okay, number 1 says f of x. So I decided on a rule that I'm going to make up. And this rule says x plus 3 squared minus 2x squared. Okay, that's the rule. Now, do you see the semicolon there? So they're telling you, I want you to evaluate this function. It says it's a function for x equals negative 12. Okay, they have the semicolon here, but they don't separate it very well. So understand that this isn't part of the function. This is telling you what to plug in for the x. Right here, we're going to plug in this function, we're going to plug in a negative 12 for all the x's. Excuse me one more time. I need to get you a calculator. Mr. Wyatt. Wyatt is such a cool name.
Named after Wyatt.
Really? That's cool.
Yeah, my dad's a big Western fan.
My husband too, he was. Okay, so what it's telling you here is in place of when you go all the way through here, every time you see an X, you're going to plug in a negative 12. Now, a good rule to go by when you're going to plug in or substitute values into a function is to always plug them in with parentheses. So here's what it's going to look like. I'm going to write this parentheses down, and then I come to an x. I'm not going to write the x anymore. I'm going to write the -12. So I need to put it in parentheses. Don't get all clogged up with all the parentheses. Plus 3 squared minus 2. I'm copying everything down. -2, plug in or substitute with parentheses, and the square goes on the outside. And so now we just need to use our order of operations that we already know how to do, but please excuse my dear Aunt Sally, to evaluate this information right here. So I see parentheses, yeah. Now, if you'll remember from when we did order of operations, we found out that if the parentheses are around just one value, like here, those aren't the parentheses that the order of operation is talking about when there's just one value in here. That's just for emphasis or to keep things
Miss
separate.
Deborah,
Okay?
where that
Yes, ma'am.
the -2 that's in the parentheses, it's supposed to be for the x, right? So it's not supposed to be a -12?
Yes. Good girl. I love you. You're amazing. Yes. We're plugging in -12. I love my students. Okay.
Yes,
Is
ma'am.
that better?
You're welcome.
Thank you, hon. Okay. And so we come down here, and again, these parentheses aren't the ones that they're talking about in the order of operation because they only have one number in it for emphasis. So this is the parentheses that we need to work right here. Okay, so we have -12 plus 3 will give us a -9, and we still put the rest of the problem down. Okay, and 2 times -12 squared. Okay, now our order of operation is, please excuse my dear Aunt Sally. The P stands for do all the parentheses first, and we just finished the parentheses. Again, these parentheses don't count because it's just one thing in there. So we're done with all of our parentheses. We move to the E, which is exponents. So we need to calculate the exponents now. So I'm going to calculate this one because it has an exponent, and this -12 squared, which has an exponent. Okay, so this becomes 81. This becomes 144 positive. Anything squared is positive. And then write the rest of the problem down. Are you all following me here? No problems? You okay?
When you do the square, is it -9 times -9? And
Yes,
then
sir.
It becomes a positive?
It will always be a positive.
And an exponent is squared in cubic, or is that anything outside of parentheses?
That's squared, just squared.
Okay.
For cubic, if it's a negative, something cubed, it will always be negative.
Okay.
Okay?
Thank you.
And this is exactly what I like in my classroom.
The question,
Yes, yes, yes.
I'll be asking a lot of them.
Works for me. All right. Now we have two operations. We have a minus and a multiply. So we've got to decide which one goes first, because if you don't do them in this order, you will get the wrong answer. So we finished the parentheses, we finished the exponents. The next one, the reason these are together is because it says do either multiply or divide, whichever one comes first, left to right. So we go through here, start left to right, and I hit a minus, that's not it, but I hit a multiply. So this is the only thing that I find the answer to in this step. 2 times 144 is going to be 288. And then again, write the rest of the problem around it. We only have one more operation. Since we're subtracting something a whole lot bigger than this, we're going to have a negative answer. You're going to find out if you use your calculator. And we have 207. 207, a negative answer. Check the back and make sure that I didn't make any more mistakes. Say -207. I always give you the answers on the back, Wyatt.
-207.
-207. Okay. Any questions on this one? They will give you a function. They will give it a name. A lot of times they use F, but that doesn't mean F for function. It just means that's the name of the rule. This tells you what's in, if the variables that's in that function, and then it tells you what to plug in. So if I plugged in a -12 into this rule, I get -207. Now understand that I can use this function over and over and over again. The next time I might want to do the function and plug a 5 in. And the next time I might want to do the same rule or function. This is a rule. And then I may want to plug a -17 in. You know, it just, you could plug anything in that you want into a function. But they give you the rule and then they tell you what to plug in. Yes, sir?
Why did we lose, on the problem we just did, why did we lose the function parentheses -12? Like, what do we do with that?
The reason that
No,
we put it in print,
The one to the left, my bad.
this one,
Yes.
it is just the instructions to tell you what we're going to be doing in this.
Okay.
This is just the name of the rule, and this is what we're going to plug in where there are X's.
Okay.
Okay, that's what this is called functional notation, and this tells you what to do.
Thank you.
Any questions there remotely, guys?
No, ma'am.
Okay, so we're okay?
Yes,
Okay,
ma'am.
functional notation. We're going to be using lots of quadratics. So let me look at the rest of page 1 and see if there's anything that might cause you trouble or that might be a little bit different than this problem. And then we'll go to the other pages. And we're going to be doing some more of the same thing. It's just written differently. Okay, it looks like all the way down through number 4, we're going to be fine. Now let's do, section A, section B, and section C are all the same thing. I'm going to talk to you about section D right here. This time it gives you 2 things to do with this function, and this might look a little scary. But remember, Brandy, just like you said yesterday, it looks scary. I think it was you that said that, or Sandra. But after we take it apart and do one thing at a time, it's not so bad. So I'm going to put this one up, and we're going to show you what to do with this number 1 on section D. Need some more chalk. You run out of chalk yet? When you go down, you might ask for another box. I'm getting there. All right, D part in the instructions, and you know, I've really encouraged you to look at the instructions. So the instructions for D part tell me what the rule is. It says f of x, which is the rule, equals x minus 2 squared. That's it. Okay, so now that's the rule that we will use over and over again. It's the one that we call the F, and we're going to solve this. I don't like to use the X because it gets mixed up with the X. So that's why I use this or a dot. Now what this actually says is we want you to use this function for here and use this same function for here. So we're really going to be doing 2 problems and using the order of operations. This number in front is exactly what you think it might be. We're going to find out what the function comes out to be, a number, and then the 4 means I'm going to take 4 times whatever that answer is. You'll see? I'm going to do the same thing over here. So let's just do one thing at a time. We're going to take this rule right here, and everywhere there's an X, I'm going to plug a 1 in. I'm just doing this part right here. So I have 1 minus 2 squared, because I plugged a 1 in where the X is, okay? So 1 minus 2 is a -1, and I'm going to square that. That gives you 1, because anything squared, if you guys will try to commit this to memory, anything squared will always be a positive answer. And then this says whatever I got when I evaluated that rule, I'm going to take it times 4. Do y'all see? And so my answer for this side is 4. And then I bring down my times. And I'm going to do it again for this side. So I want to take the same function, and everywhere there's an x, I'm going to put a 0. Okay? So I'm just doing this part first. So I have 0 minus 2 squared. 0 minus 2 is a negative 2 squared. Anything squared is positive. That means negative 2 times negative 2 will give me positive 4. And then it said, when I get an answer here, I'm going to be taking it times 6. And so my answer here is 24. And then it said, when you get an answer here and an answer here, you're going to need to multiply those together. Making sure I have everything on the screen. And so I have 1696. Check my answer for me, Rachel.
Okay.
This is D part number 1.
D number 1, 96.
96. Is there questions on this? All we do is break it down. This said what rule to use. Later on, they're going to give you an F rule and a G rule. So you just have to decide which one you're going to use. And they'll tell you right here. They'll tell you what to do. And they'll tell you what to plug in. Okay? Functional notation, and it's red f of x. F of 1, I'm saying of, f of 0. Any questions on this problem? Yes, sir?
So we got the negative 2 squared from the, like where it says x in parentheses x minus 2 squared. Is that where we got the negative 2 for to set up the function?
For this?
Yeah.
Yes, because after we do all our plug-in, then we need to do the parentheses first, which is this parentheses that they gave us. We have to find out what's in parentheses first, which we did, and then you do the exponents.
So why is that negative 2? Is it because it's the x value?
It's because, no, it's not because it's the x value. The x value is 0.
Oh,
But when you take 0 minus 2 in your calculator,
it's negative 2.
then it's negative 2.
Okay.
So we actually did the minus operation.
Okay, and then 2, would it be 2 times negative 2?
It's negative 2 times negative 2.
Oh, it's negative 2.
It's whatever's in parentheses times itself this many times. Okay.
And that's how we got 6 times 4 gave us.
The 4 came from here. The 6 came
Was a part
from
of the
here
function.
in the problem.
Nice. Thank you.
Okay. You doing okay, Reggie?
Yes.
All right. Any more questions on this type of thing? Brandy, Shaniqua, Sherry,
No, ma'am.
we're good?
Well, I would say I witnessed everything.
Now, again, you're welcome to stay on today if you need to, okay?
And you got the one on
Let's go to
F.
page
Oh.
2. I'm sorry, I heard somebody say something. What?
On the F.
Was it Shaniqua?
The
Uh-huh.
one because one for X.
I can't hear you very well. Say it one more time. On the f of x things.
Yeah, the
And what'd you say about x?
where you got on the side where you got 4 times F of X.
Oh, yeah, right here.
So you just got the one simply because there was no number, so you have to make one.
Because this is exactly what they said to do, I think. Yes. Because they said to take 4 times whatever you get when you plug a 1 into here.
Okay.
So we had to do the rule with a 1 first and get an answer, then took it times 4 because that was the problem they asked for. That's where the 4 came from and the
Yes,
6.
yes.
Okay. You'll be using a -7 down here and you won't be taking this one times anything. You'll just figure out what the rule is with a -8. Okay.
Okay.
And I will be here and you can stay on the Zoom as long as you want to, even after the recording, okay?
Okay.
Let's go to the second page. Now, the second page looks different, but you're going to be doing exactly the same thing, but you're going to fill in a chart this time. Okay. And there's another thing I want to tell you about f of x. So I'm going to write number 1 down, and then I'll show you how we're going to work it. All right. Number 1 on page 2. Alrighty, here we go. Number 1 on page 2. Okay, it's giving you a function. It's going to call it f again, and everything in the function rule is going to have x's in it. So it's 3x squared minus 6x minus 19. Now what they've done is they gave us a chart to fill out this time. They said this is x. This is f of x. Now, this is a new thing that I want to tell you about, but let's get these in. One thing I would like for you to remember, that this is called the functional notation, and we just talked a lot about that, but f of x is also equal to our variable y. So everywhere there's an f of x, we can actually substitute a y here. It doesn't make any difference in the answer. We're going to do the same thing. We're going to say y equals 3x squared minus 6x minus 19. So what we're going to do this time is we're going to work this rule 1, 2, 3, 4, 5 times. And each time we're going to plug in a different value for x. So here we go. We're going to say, okay, I want to see what this rule will be equal to if I plug a -1 in. Y'all see what I'm doing?
Mhm.
It says I want you to plug a -1 in for the x, and let's find an answer for the y or for the f of x, either one. So I'm going to write this down, but every time I get to an x, I'm going to substitute -1. So I write down the 3, here's an x, and squared. The squared goes on the outside. Minus 6 times -1 minus 19. So when we work this, we have to work parentheses, but remember these don't count as the parentheses because it only has one thing in it. So we go to the exponents. I'm going to work this only. Don't try to work this stuff fast yet. So -1 times -1, it says to multiply this times itself 2 times, and anything squared is positive. So this is going to come out 1. When things are crammed together, it's multiply. And there's 3. We're going to write down the rest of the problem. Now, it is tempting to go ahead and do the multiply also. And if you're careful, you can. But I would suggest for a while, do things in steps. Now, when I look here, we're through with the parentheses. We took care of all of the exponents. So the next thing we're going to look for is the first multiply or divide we come to, left to right. So I start on the left, just like you're reading a book. I start on the left, and this is the very first thing I come to. Again, it's tempting to do more at a time. Be careful. So the answer to this is 3, and then I write the rest of the problem down. I still have a multiply because this 6 is crammed up next to this. And when they're crammed together, it's an understood multiply. So this is what I take care of next, right here. This is a subtract. I don't do it yet until I get all the multiply and divides done. So if I'm just going to do this piece, I have a -6. I'm going to write down the rest of the problem.
And it comes to -10.
Probably, but we're going to do one more step. We're done with parentheses, exponents, all the multiply and divides. Now we're going to look for the first add or subtract that we come to. And it's this one right here. No, it's not. So we have 3 minus 6. It's going to be a -3 minus 19. -3 minus 19. And if you use your calculator, you're going to come out with a negative 22. Negative 22, because they're both negatives. Do you see them? And if they're both the same sign, you just stacked up a bunch of negatives in your hand. You have 3 of them there and you found 19 more. So you put 19 more in here. So how many negatives do I have? I put them all together. So I have a negative 22. So we found out what our rule is. If we plug a negative 1 in, I got a negative 22. And so you put the answer there. Then you get to start with the next one.
It says that it's negative 10 on the answer sheet.
So tell me what oh, I see what I did. That's why you said negative 10. Aha, I'm telling you, if it wasn't for my students, I don't know what we would do. Here's what I did, and here's what a lot of you might do. Y'all can see that I have a problem too. Okay, here's what happened. Is it still going to be? Yeah, okay. So right here, when I said the answer to this part was negative 6, so when I wrote down the rest of the problem, I failed to put this minus in there. So be very careful with those.
Yeah, that's what I did on my paper. I
Mhm.
did negative, put 3, take away negative 6, take away 19.
And when we have a minus negative, we found out that when they're together like this, we can make a plus out of it, which instead of negative 3, we have a positive 9. I don't like to make mistakes, but at the same time, I need you to see the possible mistakes. Okay, so you can watch out for those also. And so that completely changes my answer. This is a positive 9 minus 19. And so I have a negative 10 instead. Thank you. Thank you, Wyatt, and thank you, Rachel. Both of you tried to talk to me, and I just ignored you.
It's okay.
You're used to
I'm used to it.
Okay, negative 1, negative 10. So it says if you plug in negative 1 for X, you're going to get negative 10 for Y. Now let's try again, see if I can make it through, okay? Yeah, I don't like to make mistakes, but it shows me how smart you guys are and how much you're listening, that you can find my mistake. It makes me happy. Okay, so we're going to do the same rule again, but now we're going to plug in a 0 everywhere there's an X. So 3 times 0 squared, I'm coming back up to our rule. You just keep coming to the same rule. Minus 6 times 0 minus 19. Okay, no parentheses, but we have an exponent. 0 squared is going to be 0. And let's move on to the multiply. So I've got 3 times 0. 3 times 0 is 0. Minus 6 times 0 is 0 minus 19. Okay. And so if I plug in 0 to the F rule, then I will get negative 19. Okay, please tell me I'm right on that one.
Yes.
Okay, thank you. So negative 19, if I plug in 0 for X, then I get a negative 19. Now get used to this because we're going to do a lot of these. And we're going to use these to actually draw a graph on the Cartesian coordinate plane, but I'll take you there slowly. Now it says, now I want to plug in 1 for X. So I have 3. This will go much quicker when you do it on your own, but when I'm showing you, it seems like it takes forever. Okay, and so exponents, we have 1 times 3 minus 6 times 1 minus 19. Okay, we're going to do the multiplies. So I have 3 minus 6 minus 19. 3 minus 6, there's where my negative 22 comes in. So negative 3 minus 19 equals a negative 22. Okay. Any questions so far? Let's do the last two if you don't have questions.
I have one.
Okay.
With the, so when you, 3 times 1, when it's going to be 3, but what do we do with the square before you times that?
1 squared is 1 times 1, which is 1.
Oh, okay. For some reason I was thinking like 1 times 2.
Yes, and that is a normal situation. So be careful. 1 times 1 is 1. Good questions. So let's move on to our 2 and 3 and do that pretty quickly. Now we're going to plug in x equals 2. So now I have a 4 times 3 minus 6 times 2 minus 19, 12 minus 12 minus 19. 12 minus 12 is 0, minus 19 gives us a negative 19. Negative 19. Now I will tell you, and you'll see this more later, but everything that is squared, if you go far enough in your t-chart, you're going to start to repeat back. Okay? Meaning I had the negative 19 here, but I also found a negative 19 there.
Oh, okay.
If it was a straight line, you would never have those repeats. But in a quadratic, you will, if you go far enough in the t-chart. Okay, one more. You guys remotely, be sure and interrupt me.
I'm just playing.
I don't want to put you to sleep. So f of 3. Okay, this simply is the rule and it tells you what to plug in. This is the work we do. So our exponent, 3 squared, is 9, not 6. Okay, be careful about that. Minus 6 times 3 minus 19. I'm going to do this one and this one. So I have 27 minus 18 minus 19. 27 minus 18, I think, is 9. 9 minus 19 is a negative 10. So if you look at this, this is going to be the same type of pattern you're going to start to see with quadratics. Notice how the negative 10s match, the negative 19s match. This is kind of the center before they start matching again. You'll see? And that's what happens in a t-chart for quadratic. All right? So this is what they're wanting you to do on this second page. You're going to do it over and over again.
I remember this.
Do you? This is kind of where you came in, which was a tough place to come in.
Yeah.
Okay, just be careful of your negatives as I proved to you. Now, let's go to page 3. Just like I said, I give you a little bit, and then we add a little bit more, and then we add a little bit more, okay? So on page 3, they're going to have you complete the t-chart just like we did. But then we're actually going to graph those points. Now, we haven't had a graphing lesson yet, but graphing the points will be very easy, and I'm going to show you how to do that. They're not too bad. All right. So we're almost finished with the lesson, but it's turning out to be a little bit longer. Okay. Okay, on page 3, they give you a new rule, so we're going to start over. But then they give you the values that they want you to plug in for x. So we will go quicker on this t-chart now that you understand what we need to do, because I want to show you how to graph these points. Page 3, the first one, the rule is, they still called it F and it's gonna have X's in it. So the rule is X squared minus 6X plus 11. Now this is our rule. So we're gonna be using that over and over again. And the T-chart, they give us some values. They say X and Y, 1, 2, 3, 4, and 5 this time. Okay, so we're going to fill these in. This says to take this, I want to do f of 1. That means I'm going to plug in 1 squared minus 6 times 1 plus 11. 1 squared is 1 minus 6 plus 11. Negative 5 plus 11 equals 6. Then it says to put 2 in here. If I'm erasing too soon, please speak up. But I know that last one seemed like it took forever. So now I have 2's. I want to find f of 2 now. So 2 squared is 4 minus 12 plus 11. 4 minus 12 is a negative 8 plus 11 equals 3. About to run out of that chalk. So if I plugged in 2, my answer for y, remember this can be the same as y. So this said f of x on your paper. F of x and y are the same thing. Okay, so now I'm going to put 3 in, 4, and 5. F of 3 is going to plug in 3. So I have 9 minus 18 plus 11. 9 minus 18 is a negative 9 plus 11 equals 2. If y'all find a mistake, be sure and tell me. I want to find f of 4 now. So I have 16 minus 24 plus 11. 16 minus 24 is negative 8 plus 11 equals 3. Remember what I told you? See the 3 repeating?
Yeah.
What do you think this one is?
A 2.
Try again.
Probably a 6.
Try again.
A 3.
Here's the middle.
I want to see.
Here's repeats. Probably a 6. Let's find out.
16. Probably 6.
Okay, f of 5. So we have 25 minus 30 plus 11. We have negative 5 plus 11.
6.
Okay. Right. And so now we have filled out our T-chart, and that's all we had to do on page 2. But page 3, it says you need to use the chart now to graph this quadratic. Now, this is the first time you're going to see a graph of the quadratic. One thing I want to call to your attention is notice how this is a T-chart, and it's kind of weird that they call it a T-chart because why? Well, you can write it up and down also, which makes it look like a T, okay? The X always comes first. Notice how the X was on top and the Y. Well, on a T-chart that goes up and down vertically, the X is always first, then the Y. So in the X column, there was 1, 2, 3, 4, and 5. And then we have to make sure that we match the value with this. You'll see the reason why I did this. 1 was 6, 2 was 3, 1, 2, and 3, and 6. I did it first of all for you all to realize that a T-chart can be done this way and it can be done this way. All right. The reason that this is going to be easier to use to graph is because now that we have values for X and Y, that means that this is actually a point on the graph.
Mm.
Here is your coordinate graph. This will always be the x-axis, the one that comes this way. This will be the y-axis, the one that is vertical. Okay, so if I am going to graph this point, it's not a 1 and a 6. The point is 1, 6. You have to do both of these. Now on a coordinate graph, for those of you that have never done this, it looks like this. Whoops, wrong way. See this coordinate graph right here?
Mm-hmm.
This is a huge one. This horizontal line is called the x-axis, and this vertical line is called the y-axis. And when I look at something like this, a coordinate graph, then I think this kind of looks like a city to me. And each one of these are north and south and east and west roads, right? And so I imagine people living on these corners right here, you know, the intersections. I think about them living there. And these points that I have in the T-chart are like the address for somebody's house. Okay, now understand that in the address, the X comes first, then the Y. And so I'm going to go find Wyatt's house. Wyatt lives at 1-6. Okay, and so what I'm going to do, I always start at the origin, which is called 0, 0. I start right here all the time in the center of the city. And to get to Wyatt's house, I have to go 1 block on the x-axis, which is horizontal. And then I have to go up and down on the y. I need to go 6 blocks. So I start in the center of the city and I go 1 block horizontally. This is the x-axis. So from here, I go 1 block. And then I turn because now I need to go up and down. I'm going to go up 6 blocks. 1, 2, 3, 4, 5, 6. So this point right there is where Wyatt lives. Okay. Then let's do the next one. This is this first point right here. Now I'm going to go to where Rachel lives. She lives at 2, 3. Is it right? You live at 2, 3. So we're going to go start at the center of the city, and we're going to go 1, 2, and then 1, 2, 3. So she lives there. I think Sherry lives at 3, 2. Here's the next. This is Sherry's house. We start at the center of the city. We go 3 on the horizontal x-axis, 1, 2, 3, and up 2. This is where Sherry lives. And then Shaniqua lives at 4, 3. 1, 2, 3, 4. 1, 2, 3. And who else? Shaniqua, Sherry, and where's our other? Somebody left us. Brandy. Brandy had to leave today. Yeah. But we'll do Brandy's house. Brandy's house is at 5, 6.
Yes.
Okay. So we're going to go start at the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So this definitely isn't a straight line, and anything with the exponent of 2 isn't going to be a straight line. So what we're going to do is do a dot to dot here. And this will be the graph of a quadratic. I hope y'all can see this online.
Yes, ma'am.
This is called a parabola, and every quadratic will make a graph of a parabola. A parabola. So it's going to look like this. Now, it's not a U. I want to make sure you guys know that it's not a U. It comes out and out and out and out. It doesn't go straight up. Y'all see?
Mm-hmm.
And right here where it turns, it's not a V. It's curved here where it goes through this bottom point. Now that bottom point right here is called a vertex.
Yes.
It's called the vertex. V-E-R-T-E-X, the vertex. I know I'm going over the time I usually do. We're about done. I'm going to show you right now what page 4 says, because you're going to be doing the same thing again, but you're going to be finding the zeros. Now this is really weird, but you're going to be finding the zeros of the parabola. So if I have a parabola, and you guys know now that you can have a right side up parabola or you can have an upside down parabola. They're both parabolas, and this is the vertex. Okay, now page 4 asks you to find the zeros. The zeros are so easy. Let's pretend that we graphed this.
Is it the -2 and +1?
Not sure because I didn't look at the problem. Let's say that I graphed a parabola and it was right here. The zeros are this number on the x-axis and this number on the x-axis.
Yes.
So let's say this is -3. That's one of our zeros because it crossed the x-axis right there. And let's say this one is 5. So my zeros for this parabola and this function are where they cross the x-axis. That's all you have to do is look at where it crosses the x-axis, and those are your zeros. Now you may have 2 zeros, which is pretty common, but look at this one that we graphed. Notice that it never ever touches the x-axis, right? So you can have no zeros. This has no zeros because it never touches the x-axis. And you can also have 1 0. Let's say when you graph, your parabola comes like this. And it only touches the x-axis 1 time. So this particular parabola only has 1 0. So your parabola could have 1 0, no zeros, or 2 zeros. And all of this hopefully will come together when you start your worksheets. Any questions on these 4 pages? This is packet 1. Any questions?
No, ma'am.
Sherry, are you dizzy?
She has her on mute.
Yes, I am.
Pretty dizzy. Shaniqua, I think you said okay.
Yes, ma'am.
Okay. So I'm through as far as recording for today. I'm going to turn the recording off. Those of you that are remotely with me today can stay on.